Hello and welcome students. Today I am going to discuss about atomic radius and ionic radius. So first of all, atomic radius. Atomic radius is the distance from the center of the nucleus to the outermost shell containing electrons. In other words, it is the distance from the center of the nucleus to the point up to which the density of electron cloud is maximum. Types of atomic radius. Atomic radii are divided into three types: covalent, van der Waals, metallic. First is covalent radius. So what is covalent radius? It is half the distance between the nuclei of two like atoms joined by covalent bond, like Cl2. This is the molecule of Cl2, and here we can see the atomic radius of Cl. Second is metallic radius. Metallic radius is the half the distance between the nuclei of two adjacent atoms in pure solid metal like So the metallic radius is the half distance between the nuclei. This is half distance between the nuclei of two adjacent atoms in pure solid metal like aluminium. This is metallic radius of aluminium. Next is van der Waals radius. Van der Waals radius is half the distance between the nuclei of two like atoms, such as argon, that are not closely packed but not bonded. Here we can see two atoms of argon. They are closely packed but non-bonded. In covalent radius, these are covalently bonded. Two chlorine atoms are covalently bonded. Now, difference between covalent radius and van der Waals radius. So, this is the depiction of covalent radius and van der Waals radius. This is covalent bond या covalent radius of van der Waals chlorine, and here covalent radius and van der Waals radius of another chlorine atom. These two chlorine atoms are adjacent to each other but not bonded. So this point to this point we can say van der Waals radius, but this point to this point is covalent radius because two chlorine atoms are covalently bonded in this chlorine molecule. Now we see the periodic trains in atomic radii. So here we can say atomic radii from top to bottom or going down to a group. Here covalent radius increases as we move down in a group because here is the addition of new valence shell. Okay. Since the number of electrons has larger effect than sizable nucleus. For example, lithium has a smaller radius than magnesium. Diagonally, we can see here diagonally also atomic radius increases. Sodium, calcium. Now, across the periodic table, atomic radii decreases because the atom number increases but number of shells are not increases. So, extra electrons are only added to the same quantum shell. So, lithium has larger size than fluorine. Therefore, the effective nuclear charge towards the outermost electron increases, drawing the outermost electrons closer. As a result, electron cloud contracts and atomic radius decreases. Why? Because of the presence of shielding effect or screening effect. Now, ionic radius. Ionic radius is the distance between the nucleus and electrons in the outermost shell of an ion. When an atom loses one or more electrons, it becomes positively charged and is known as cation. Conversely, when atom gains one or more electrons, it becomes negatively charged and is called an ion. General trains. Periodic trains. Cations have a smaller size or smaller atomic radius than neutral atom they are made from, while anions have always larger atomic radius than an atom they originate from.